Hi guys, so my name is Max. I'm one of the SIs for Dr. Maduro's 5A class, and today I'm going to be talking about ploidy and a little bit of mitosis and meiosis. Okay, so for questions like these where we deal with, the aforementioned topics, you probably want to think of diagrams, draw them out. I think that helped me a lot. If drawing it doesn't help you, maybe looking up videos on kind of the progression of how these things work, and seeing it in that different context could definitely help you understand these topics a bit more. Specifically, anything that has to do with like these events happening in a series, they help a lot in terms of understanding what's happening in the cell at any given time. Okay, so at this point, you guys should have seen mitosis and the meiosis modules that Dr. Maduro posted. And if you need to review those, go ahead and do so. I'm going to assume that we're all pretty much on the same level here and we're all okay with it. The point here is that you guys know that sometimes meiosis or mitosis in general just fails and you don't separate the chromosomes properly. And this will create issues with non-disjunction and all that stuff where the chromosome number is just not the one that you want it to be, right? And so the question here states that we have our male sperm and it stays as a diploid and it fertilizes a female egg. I'm gonna kind of put this in a green box here. We fertilize a female egg that is haploid. Okay, so let's do that one first. So we know that generally, and let me make this a little bigger, we have our sperm, right? If this was the sperm head, has its tail, right? The nucleus is 2N, like we said in the question. We have our egg cell, right? And our egg cell has its own nucleus, and the nucleus here is N, right? At some point, this nucleus here is going to enter the egg cell, right? And it adds on to this nucleus here. There's a fusion, and we know that the resulting nucleus would be 3N. Okay, and so let me draw that here on the side. It's kind of like an addition question here, I guess you can think of. That would mean our egg cell here would have a nucleus, and I'm going to put this in a different color just to denote the change. So now our nucleus is 3N, right? And again, that's just because we added 2N and N. So right now we have 3 copies of the chromosomes, or whatever chromosomes that we have. And now let's think about the next part of the question. It's asking us how many copies would be present after the zygote divides for the first time, right? Zygote being this thing over here, the fertilized egg. Okay, and so we might be thinking, well, are we dealing with mitosis? Are we dealing with meiosis? Remember that when we're dealing with a zygote, this is going to be a mitotic division. Okay, so it's not going to be meiotic just because we're not looking at the division of sex cells. We're looking at the division of, I guess you can think of in this case, a body cell where you need to develop the rest of the body first before you can actually, start producing those sperm and egg and all that stuff. Okay, so we're looking at mitotic divisions. So let's just make sure we're on the same page for mitosis here. We know that if this was our parent cell, and I'm going to draw it up in this top right corner, this was our parent cell, right? If this was 2N, or let's say we just had our chromosome over here, right? We know that the daughter cells would be an exact copy of that, right? At some point, we split into 2. That's because we would split this chromosome over here. Let me make that a bit nicer. We split the chromosome, right? And in the nucleus, we have this one as 1/2. In this cell, we have another half. And then they go on to replicate it, and then you end up with identical cells to the parent, right? So they're identical to the parent. And again, these are the daughter cells. I'm going to put a D right there. And these are the parental cells, or mother cell, and I'm going to label as P. Okay, and so we can see that what's conserved here is that we keep the number of chromosomes, right? And we also keep the number of, I guess they're just identical clones, or they're clones of the parental cells, the daughter cells being, right? And so you can think of them that way. So if we think about our zygote here, which is 3N, we know that it's going to have daughter cells, right? And we can kind of safely assume that since we have 3 copies of the same chromosome, it's going to split into 2 different cells over here. I'm going to try to draw these. They're going to be slightly smaller, so bear with me. And each of them is going to have kind of what we had over here in this nucleus. And I'm going to put that in the same color. In this nucleus over here, we have like 1/2 of each of the chromosomes that we had in our zygote. And then in this guy, we had another 1/2 of the chromosomes that were in the zygote, right? And then if we do the same thing, we can see that this will progress to the point where we have 2 identical daughter cells, and each one, I'll try to fit in the actual drawings here, where each one has 3 chromosomes, and bear with me, it doesn't look the best, but each one has 3 chromosomes, right? And they're now the clones of the zygote. Okay, so it's duplicated it's divided once, and now we're thinking, okay, how many copies of the genome do we have? And fertilization's a bit different. How this works is it's kind of encapsulated in an area, right? So I'm gonna just put this in black. So it's encapsulated in an area. So it's not like these are 2 independent cells now. It's still encapsulated in the same area and still encapsulated in the same area. I just drew them separately to kind of make the point here. However, we know that in this whole area, each of these, right, each of these 2 daughter cells, this one is 3N, this one is also 3N. As a result of that, we can figure out that 2 3N copies would mean 6N, right? And the 6 refers to the number of copies of the genome we have, while N refers to the chromosomes, right? So the best answer here would be 6. Okay, and if you have any other questions about this, go ahead and ask your SI about them. We have our usual times, and all the SIs are more than willing to help you through email or any other means that you have to contact them. All right.